This week we are going to look at Chapter 7, Correlation. So before we begin this lecture, let's talk about the word correlation, and let's just break it apart for a second. So the prefix co means two, hence correlation is about the relationship between two things. So a correlation involving two variables is sometimes referred to as a bivariate correlation, and it's noted using the lowercase r and has a value between -1 and 1. So correlations, this is going to be our r value, and so anytime we're looking at a correlation, it's always going to fall between that range, -1 and 1. Now there are two primary attributes of a correlation. We have the direction of the correlation and its strength. And let's look at these two attributes. So first let's look at direction. So for direction, it's going to be our R value will either be a positive or negative. So our direction, it's only going to fall either positively or negatively. So positive correlations, which this would fall within the range, our R would be somewhere between 0 and +1. And this would emerge when the two variables move in the same direction. So for example, we would expect that low homework hours would correlate with a low GPA, just as we would expect that high homework hours would correlate with a high GPA. Now negative correlations would be R would fall anywhere between -1 and 0. So negative correlations emerge when two variables move in different directions. So before, where you're only doing homework for a few hours, it's likely that your GPA is going to be low. Or if you're working lots of hours doing your homework, you would have a high GPA. Well, a negative correlation, they're going to move in two different directions. So for instance, if we see high alcohol consumption, we can say high alcohol consumption would correlate with a low GPA. So if someone's drinking a lot, it's likely that they would have a low GPA. And we can flip this situation over as well. We can say low alcohol consumption would correlate with a high GPA. Now strength is indicated by the numeric value, by a numeric value. So close to 0 is going to be considered weaker than those nearer to -1 or 1. So for instance, we can have a strong negative correlation between alcohol consumption and GPA. So that's telling us that there is a strong relationship between those two variables. So R would be -8.1. Or we can say that there's a strong positive correlation between homework hours and GPA, which would give us an R of +8.1. Or we can even say, what if we are looking at the relationship between height and GPA? Now realistically, we know that there's probably absolutely no relationship between height and GPA. So we are looking at, it would most likely be a relatively weak correlation. So R of +0.02 or R of -0.02. Now remember, notice I keep saying relationship. So correlation, we're only looking at the relationship between two variables. We are not looking at a cause and effect. One variable is not influencing the other in a correlation study. We are only looking to see if there is a relationship between the two, not a cause and effect. Let's look at this table here. This will give you a better visual. So if we have an R of 0, that means that there is absolutely no correlation, no relationship between two variables. Now we can have a positive correlation, which our numbers would be positive, okay, and we can have, it would fall under the weak category, moderate, or strong. So you can see anything from 0.2 to about 0.5 would be considered weak. From 0.5 up to about 0.8 would be considered moderate, and strong would be 0.8 all the way to 1. Now, in a minute, we're going to look at several different scatter plots, because scatter plots is often used as a way to illustrate correlation coefficients. And we can see that, we'll see in a minute that the correlation coefficient changes as the linear relationship between the two variables is altered. So, for instance, when r is 0, remember there's absolutely no relationship whenever r is 0, those points are going to scatter widely about the plot. There is not going to be a linear relationship. It's not going to fall on a line. So the more scattered that these plots are, the less of a relationship that there is between those two variables. So as the linear relationship increases, whereas before these plots were just scattered in almost like a circle, now this circle is becoming more and more elliptical in shape until that limiting case is reached, meaning that range whenever it reaches either 1 or -1. And it's very unlikely that you will ever have an R of 1 or -1. It's always going to fall in between those two values. But the ideal case is that we want them to fall on a straight line as much as possible. If we are examining to see if two variables have a linear relationship, we want them to fall on a straight line as much as possible. We want them to have a strong relationship. So let's look at a few examples. So this is an example of a perfect linear relationship. Okay, perfectly positive linear relationship. As the values of x increase, the values of y increase at the same time. Now this is an R of -0.54, and this is a moderate negative correlation because these two values they're going in two different directions. So we have our values on x. As our values of x are increasing, our values of y are actually decreasing. Here's an example of a strong positive correlation. Again, our values are both increasing, our variables are both increasing, x and y are both increasing at the same time. So hence, notice how strong it is, 0.85. We have our strong negative correlation, where again we have our values in y are decreasing while our values of x are increasing. Here is a moderate positive correlation, so notice it's an R of 0.42. So you can see it's pretty scattered here. Probably an R of 0.42 is probably not a correlation that we would want to see. It's probably not a relationship that we would like to see if we're examining the strength of this relationship. So only moderate, only moderately positive. Here is a weak negative correlation. So again, notice that as our numbers get closer to 0, notice how more widely our plots, our dots, our plots are getting scattered around our linear line. Much less of a line for sure. So notice here's our weak negative correlation. Again, notice that it's starting to form a circle. Our plots are just kind of scattered all over the place. So definitely not a relationship between these two variables. Here is probably a weak to moderate positive correlation, so our variables are going in the same direction, but again, not much of a relationship as well. So here is an example of a correlation study. And we're actually, I will start it off in this PowerPoint, and I'm actually going to finish it up in part 2 where I will actually go through the steps in SPSS to complete this particular study. So for instance, what if a researcher believes that there is a correlation between the number of hours a student spends doing homework per week and her GPA? Sorry about the typo. He would like to investigate this. So again, our same example from the beginning of our PowerPoint. And so the research question, his research question is there a statistically significant correlation between homework hours per week and GPA? So we're looking to see, is there a significant correlation between the two variables? Now, notice, so what if we had to write our hypotheses? We have our null hypothesis, and notice that there are actually two alternative hypotheses here. Okay, our null hypothesis, remember, whenever nothing notable happened, there is absolutely no effect, there's absolutely nothing going on in this particular study. So if there is a null effect, our null hypothesis would be that there is no correlation between homework hours and GPA. Now, what if there is an effect, though? What if there is a notable effect? Well, there's two things that could possibly happen. So that's why there are two alternative hypotheses here. So there could be a positive correlation between homework hours and GPA, or there could be a negative correlation between homework hours and GPA. Okay? So notice for our correlation study, there are actually three hypotheses, one null hypothesis and two alternative hypotheses. And we're going to end right there. The next part two of my lecture I'm going to actually go through the steps of completing this correlation test in SPSS.